All right, today we're diving deep into a really interesting piece of tech called Warp. It's an intent engine built by the team at Rhinestone, and it's aimed at developers who are building the next wave of multi-chain apps. We're going to break down its architecture, figure out what makes it so incredibly fast, and see what it unlocks for anyone building in crypto.
You know, this quote from the Rhinestone blog really just nails it. The crypto experience right now, it can be a total maze of friction. You're juggling gas tokens on different chains, trying to figure out bridges, signing these cryptic messages. It's a lot. Warp is basically engineered to make all of that disappear, turning complex cross-chain stuff into what it should be. A single, simple click.
So here's how we're going to break it all down. First, we'll set the stage with the multi-chain problem. Then we'll introduce Warp as the solution, this intent engine. After that, we'll pop the hood and look at the architecture, find out the secret behind its speed, and wrap up with the toolkit it gives to developers.
Okay, let's start with the big problem we're all trying to solve. The multi-chain world is amazing, right? But it's also a fragmented mess. For users, it's a constant headache. And for developers, it's this tangled web of integrations that's just a nightmare to manage.
And this really shows the difference between yesterday and tomorrow. On the left, you've got the old way. You know the drill, signing multiple transactions, making sure you have gas on 3 different chains, manually bridging funds, and signing transaction hashes that look like gibberish. But on the right, that's the Warp way. A single, readable signature, gas is just handled, and everything is automated in one click. The key thing to get here is that the complexity doesn't just vanish, it's just hidden, made invisible to the user.
And that's exactly where Warp comes in. It's not just another tool. It's designed to be a whole new foundational piece of the puzzle, a primitive that completely changes how we interact with apps across all these different blockchains.
So, at its heart, Warp is what's called an intent routing and execution engine. What does that mean? Well, think of it this way. Instead of giving your GPS turn-by-turn directions, you just tell it your destination. With Warp, a user doesn't create a complex transaction. They just declare their goal, their intent. They say, I want to deposit 100 USDC into Morpho on Arbitrum, and the engine figures out the best way to make that happen, automatically. Okay, so we know what it does. Now let's get into the fun part, how it does it. Let's really get under the hood and see how this system is put together. So this is the entire journey of an intent, from start to finish. It all starts when you sign one simple, readable message. That intent gets shot over to an off-chain brain, called the orchestrator, which finds the cheapest, fastest route. Then it puts that job up for auction in a market of relayers, or solvers. The winning solver immediately fronts their own money on the destination chain to get your transaction done instantly. Only after it's all complete do they get paid back on the origin chain. This whole sequence is what makes Warp tick. Let's quickly break down those 3 core pieces. You've got the orchestrator, that's the brains of the operation, the master planner. Then there's the on-chain routing engine. Think of this as the hands, the smart contracts that actually talk to all the bridges and protocols. And finally, the relayer market. That's the competitive arena where solvers battle it out to execute your intent as efficiently as possible. Now, here's a really smart design choice. Warp isn't trying to be another bridge. Instead, it aggregates a bunch of different settlement layers. It's like a travel aggregator, like Kayak, but for block space. It lets the orchestrator pick the best tool for the job. Need top-tier, trustless security? It'll use Across. Need to get to some obscure token on one of 70+ chains? It can tap into Relay. Just need to move stables fast and cheap? It'll use Eco. This modular approach means you always get the best route. So aggregating all these layers is powerful for sure, but it doesn't quite explain the incredible speed. The real secret sauce, the thing that allows for that near instant experience, is a really clever bit of technical innovation.
And that secret is something called the compact.
So, what exactly is the compact? Well, at its heart, it's a special kind of smart contract, an ownerless ERC 6099 contract, to be precise. And its whole job is to let you lock your resources. Think of it like putting funds in escrow. By doing this, you're making a credible commitment. You're basically broadcasting to the world, hey, these funds are earmarked for a specific job. And because that commitment is credible and on-chain, third parties can act on it immediately, asynchronously, without waiting for a bunch of other stuff to happen first.
And this wasn't just built by one team in a silo. This is a pretty serious collaborative effort.
We're talking about Rhinestone, Uniswap Labs, and LFI all working together on this. So you know it's got some serious brain power behind it.
Okay, check out this new flow. It's totally different. Step 1, you do a one-time lock of your funds. The key here is they never actually leave your wallet's control. Then, step 2, you just sign a message off-chain for what you want to do. That's it. Now a relayer sees that signature, and because your funds are locked, they can trust it. So they immediately and optimistically go and fill your request on the other chain, using their own capital. And only after your transaction is done do they go back and claim your locked funds as reimbursement. It's a fill first, claim later model, and that changes everything.
So what are the benefits of this inverted flow? Well, first off, it is blazing fast. Your intent gets executed at the speed of the destination chain, because you're not waiting for the origin chain to slowly process things anymore. It also creates this incredible feeling of a single, unified balance. It feels like your money is just everywhere at once, ready to be used. And finally, this idea of delayed settlement, it opens up all these new possibilities for optimization. Relayers can batch things, find better routes, and ultimately save everyone on gas.
Okay, so this all sounds great in theory, but how does it actually work under the hood? Let's break down the core components, the technical engine that makes the compact tick.
First up, we have the ERC-6909 contract itself. Now, if you're not familiar, ERC just stands for a standard on Ethereum. Think of it like a blueprint. This specific one, 6909, is the base layer. This is where you actually deposit your tokens to create that resource lock we've been talking about. In exchange, the contract gives you back a different token, an ERC-6909 token, which basically acts as your claim check, your receipt for those locked funds.
The second component is something called allocators. The best way to think of these is as the off-chain traffic controllers. They operate off-chain, which is key for speed. Their job is to watch all the user intents, keep a running account of everyone's locked funds, and co-sign everything to make absolutely sure nobody can double spend. You can't promise the same locked USDC to two different relayers. The allocator prevents that. It's the central nervous system for accounting.
All right, component number 3, the arbiters. So after a relayer has optimistically used their own funds to fill your request, the arbiter is how they get paid back. This is a smart contract, so it's on-chain, and it acts as the official referee. It processes the relayer's claim, checks all the signatures, and then directs the funds from your lock to the relayer. This on-chain guarantee is the whole reason relayers are willing to fill your intent in the first place. They know the arbiter will make sure they get paid.
And the last piece of the puzzle is the emissary. Now this is a really clever, optional piece designed for smart accounts. You see, with smart accounts, you can rotate your keys, which is great for security. But it creates a problem. What if a signature becomes invalid before a relayer can claim their funds? The emissary solves this. It's a delegated signer that doesn't change when you rotate your main keys. It ensures that a relayer's claim is always valid, guaranteeing they get paid. It's a crucial little detail that makes the compact ready for the world of smart accounts and passkeys. The impact of a system like this is huge. First, it's trust minimized. The system only ever has control over the specific funds you decide to lock, not your entire wallet. It also has maximum interoperability. It doesn't get in the way of your wallet's normal functions. But maybe the biggest thing is composability. It's a permissionless foundation. That means anyone can come along and build new, cool intent systems on top of it. And, of course, it's smart account ready, built to work with things like session keys and passkeys right out of the box.
So what's the result of all this? How fast are we really talking? Well, get this. The average time for a relayer to pre-confirm they're taking your job is just 500 milliseconds. Half a second. That's from the moment you sign to the moment you know it's happening. That's basically Web 2 speed.
But wait, it gets even better. The average time for your intent to actually be included on a destination L2, even if the money is coming from Ethereum's main net, is under 1.5 seconds. For anyone who's ever waited for a bridge transaction to complete, you know that is absolutely mind-blowing.
And again, all this speed and certainty is possible because the relayers are the ones fronting the funds. This is fantastic for the user. It means the output is deterministic. What you see is what you get. No more nasty surprises with slippage. It even helps protect you from things like MEV, because the complex routing is handled by a pro.
Okay, so we've covered the architecture and the crazy performance. Now, let's pivot and look at what this means for you, the developers. What's in the toolkit, and what new features does this unlock?
So if you use the Warp SDK and API, you get a whole suite of powerful features right out of the box. You get fee abstraction, so your users can pay gas in any token they have, or you can just sponsor it for them. You can bundle complex, multi-chain actions into a single click. You get those awesome legible signatures we'll look at in a sec. It even has tools for transaction automation, and crucially, it's designed to be modular. It works with modern smart accounts, but also with regular old wallets. And this right here brilliantly illustrates the leap in user experience and security. On the left, you've got a typical transaction hash. It's just a scary string of characters. Who knows what you're actually signing? But on the right, you have an EIP 712 signature from Warp. It's structured, it's clean, and it's human-readable. Your users can see exactly what they're authorizing. It's a massive win for transparency and peace of mind. When you step back, what systems like Warp really represent is a fundamental shift. We're moving away from a world where users have to manage all the blockchain complexity themselves to a world where our applications handle it for them. It turns these painful multi-step journeys into a single click. And that's not just a minor improvement. It's a foundational change that opens up a whole new universe of possibilities. So it really leaves us with one question for all the developers out there. When cross-chain actions become this simple, what are you going to build?